Hey guys, it's Mr. Krieger. This is Unit 8, Part 2. Lesson 9, this is the last lesson of the unit. We're going to do some more directed line segments, and then we're going to do one other type of problem. You'll see in a few. The first three problems of this unit, of this lesson, are actually problems that you should be able to do on your own. They're just more practice from what we've done on the last lesson. So what you should do is you should try them, and then you can watch me do it, to check to see if you did it correctly. All right, so let's take a look at this first problem. The endpoint of the line segment AEB are A is -2, 4 and B is 7, 1. Determine and state the coordinates of point E if the ratio of A to E compared to E to B is 1 to 2. All right, so the first thing you should do is you should add these together. So 1 plus 2 makes 3. We're going to have to break this line segment up into 3 equal parts. As I had told you before, one thing you should do is you should draw yourself a line segment with the left point here. That's -2, 4. The right point here, 7, 1. And if we have to break it up into 3 parts, it means we need 2 marks, because 2 marks is going to make 1, 2, 3 parts. All right, so now what we need to do is we need to figure out how we're going to find the x values of each of these points here. All right, so what we do is we're going to first subtract the x values, the x value from the right minus the x value from the left. So 7 minus -2 is actually 9. You're going to take that 9 and divide it by this number 3. That means you're going up by 3 units each, starting from this x of -2. So from -2, you're going to add 3. That brings you to 1. 1 plus 3 is going to bring you to 4. And just to double check, 4 plus 3 will get you to 7. So that makes sense that you would be going up by 3. Now we're going to do the same thing for the y's. So you're going to go to the y value, 1 minus 4. 1 minus 4 is -3. You're going to take -3 and divide it by 3. That's -1. It means your y values are going down by 1. So here, x's go up by 3 each time, but here the y's go down by 1. So starting with this 4, 4 minus 1 is 3. 3 minus 1 is 2. To double check that, to see that we get to the right endpoint, 2 minus 1 is 1. We've gotten the correct values here. Now we just got to figure out which of these points is going to be the point we want to pick for our answer. We want to break the segment into a ratio of 1 to 2. 1 part here, 2 points on this side. This is going to be the location that separates it. That's going to be point E. So point E is the point 1, 3. So that's how you do this. And it's the same thing basically for all these problems. So again, pause the video, try this problem, then unpause the video and just check to see if you did it the same way I did or if you got the same answer. All right, so the coordinates of the endpoints of AB are A is -8, -2, and B is 16, 6. So, and we're going to find a point P that breaks the segment into a ratio of 3 to 5. That's going to give us, if we do this first, 3 plus 5 is 8. We're going to have to break this segment up to 8 parts. So leave yourself a lot of space and write small. A is going to be here. That's -8, -2. -8, -2. And B is way over here. And that's going to be 16, 6. Okay? And since we have to break it into 8 parts, we need 7 marks. So I'm going to try to make these close enough together. 1, 2, 3, 4, 5, 6, 7. I probably could have spaced a little better, but this is the best I could do under the circumstances. You know what I'm going to do for space's sake? I'm going to alternate going up and down like that. So the next point I'm going to put here, and then I'm going to put a point here and here, just this way they don't run into each other. Okay, so what we need to do now is we need to subtract the x values first. So we're going to do 16 minus -8. Put that into a calculator, it's going to give you 24. You're going to take 24 and divide it by 8. That gives you 3. That means your x's are going up by 3 units each. Oh, so -8 plus 3 is -5. -5 plus 3 is -2. -2 plus 3 is 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. And 13 plus 3 is 16. That's exactly where we should wind up. Let's try the y values. 6 minus negative 2 is going to give us 8. 8 divided by 8 is 1. So the y's are going to go up by 1s. So starting from negative 2, we're going to go to negative 1, then 0, then 1, 2, 3, 4, 5, and 6. Perfect. Now we just got to find the location. We're breaking it into a ratio of 3 to 5. 3 parts to the left, 5 parts to the right. 1, 2, 3. Right there is going to be our breakup right there. 1, 1 is going to be choice number 1. Okay? So you see the procedure that you follow here, always the same kind of thing. And so as long as you follow the procedure, you'll be able to get the right point. All right, let's go take a look at the next problem. Okay, so here we've got a problem. Give me 1 second. Here we got a problem where it says point P, and again, I paused the video, try out the problem, come back and see how I did it. Point P is on a directed line segment, starting from point X, negative 6, negative 2, to point Y, 6, 7, and divides the segment into a ratio 1 to 5. Okay, so let's make our line segment. X is here, it's the leftmost point, negative 6, negative 2. And Y is here, and that's going to be 6, 7. We need 1 plus 5 is 6. 6 parts, so we're going to make 5 marks. 1, 2, 3, 4, 5. I spaced it nicely this time. And what I'll do is I'll just again alternate so this way I get room. All right, so what I'm going to do is we're going to subtract the x's. 6 minus negative 6 is 12. We're going to do 12 divided by 6 is 2. So we're going to go, this is how we're going to change our x's. X's go up by 2. All right, so from negative 6 to negative 4, negative 4 to negative 2, negative 2 to 0, 0 to 2, 2 to 4, 4 to 6, perfect. Then the y, so we're going to do 7 minus negative 2 is 9. We got to do 9 divided by 6. Well, if you put that in your calculator, 9 divided by 6 is 1.5. So we're going to be going up by 1.5 units. It's up by 1.5. Let's see how that goes. Negative 2 plus 1.5 is negative 0.5. Add 1.5, that brings us to 1. Add another 1.5, that brings us to 2.5. Add another 1.5, that brings us to 4. 4 plus 1.5 is 5.5, and if we add another 1.5, we get to 7. Perfect. We're doing that ratio 1 to 5. 1 here, 5 there. This is going to be the point. Negative 4 comma negative a half. Negative 0.5 is equivalent to negative a half. That's choice number 4. Hopefully you did it yourself, and you can see that the technique is, you just do the same thing over and over again. You always get the right answer. All right, now we're going to change gears a little bit here. This is a similarity problem, but it also involves volumes. So it's a combination of similarity and volume. This has nothing to do with a directed line segment, just like one of those odds and ends that we thought would be important for you to see. Let me read the problem. It's an actual regions problem. It's in 4 parts. Actually, is it 4 or 3 parts? It was multiple parts to this question. And let's read the question and see how to deal with it. A water glass can be modeled by a truncated right cone. See, you have a cone. And by truncated, we mean you cut off the bottom part and kind of fix a little piece on the bottom to make it to make sure nothing, no liquid drips out of it. You seal up the bottom, and that creates this cup, right? And what they've done is they've cut the cone here parallel to the top of the cone to create the bottom piece of the cone, right? So a cone which is cut parallel to its base. The diameter of the top of the glass is 3 inches. So from here to here is 3 inches. Basically, it's the same value as you would have here. The diameter of the bottom of the glass here is 2 inches. So that's 2 inches. So from here to here is also 2. And the height of the glass is 5 inches. So basically, this line that would go from here to here, I'll also measure it out this way. That's 5 inches, okay? So basically, from here to here, that's 5. Okay? Because this is that. All right, the base with a diameter of 2 inches must, here's the first question. It says, the base with a diameter of 2 inches, that's this part right here, must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Basically, this full height of this cone. Explain why. Why does this have to be parallel to this? Well, what we want this cone, see, I don't know if you noticed this, but this, if you cut the bottom off, there's a cone at the bottom. And the original cone is this big cone. So essentially you could think about it in 3 parts. The original big cone, right? Then there's this bottom cone which you're cutting off. And then the cup that's left, this weird shape here, the cup shape, right? But it's not a shape that we have a formula for. So in order to find the height of this full cone, we could use the concept of similar cones or similar triangles. But in order for the triangles to be similar, these have to be parallel. Why? So here's an explanation. The parallel bases, so please write this down. The parallel bases, and this is a base here and this is a base here, like this, these pieces right there. The parallel bases guarantee that the triangles will be similar. And I'll use this symbol for similar, okay? Therefore, corresponding sides will be in proportion. Be in proportion. Now, you might say to yourself, but how do you know that the triangles are similar? Well, here's the idea. If these are parallel, then this line with this line will make a right angle. This line with this line will make a right angle. So, and let me show you something here. I'm going to color this bottom triangle with yellow. Okay, the bottom triangle, not the cone, but just the triangle. I'm going to outline the bigger triangle in purple here. This bigger triangle here, I'm going to outline it in purple. Now, look, the big triangle has a right angle, the yellow triangle has a right angle. They both have this bottom angle here. This big triangle and the yellow triangle have this reflexive angle right here. And if you want to, these are corresponding angles right here. So by angle, or even angle, the yellow triangle and this big purple triangle have to be similar. If the triangles have to be similar, then we should be able to make a proportion to find the missing pieces, as we'll see in the next problem, because this is what it's asking in the next part. It's saying, determine and state in inches the height of the larger cone. So the height of the larger cone is actually this. We'll call it, actually, you know what I'm going to do? I'm not going to call it X. I'm going to call this piece X from here to here. And this piece, the height of the big cone is going to be X plus 5. So what I'm going to do is I'm actually going to draw this triangle over here so you can view it separately. So that's supposed to be the big cone. And then I'm going to draw this line across it right here, okay? This piece was X, this piece was 5. Let's go back over here. If this diameter is 3, this is 1.5 inches, so this is 1.5 inches. If this is 2, we know this whole thing is 2, so this little piece here is 1, this is 1. So now we can solve the proportion to find out what X is, and we could also figure out the height of the big cone, which will be X plus 5. Now you just need a proportion. You could just do 1.5 is to 1 as, now we did the big cone first, the top part of the big cone, so now we got to do the left side of the big cone, which is X plus 5 or 5 plus X. So 1.5 is to 1 as X plus 5 is to X. Part to part, corresponding part to corresponding part, corresponding part to corresponding part. Now we could cross multiply this. You get 1.5x equals 1 times x plus 5. 1.5x equals x plus 5. Subtracting x on both sides, we get 0.5x equals 5. Dividing by 0.5, we get x is 10. This piece here is not drawn to scale, but this piece here is 10. This piece here is 10, okay? So now what we're going to do, because the last part is saying to find to the nearest cubic inch the volume of the water glass. So you know the concept here. Find the volume of the big cone. Find the volume of the small cone. And the difference will be the volume of this piece, which is the water glass, okay? So because it's a cone, we're going to use the formula 1/3 pi r squared h. That's the formula for the volume of a cone, okay? We have two cones to deal with. We have the big cone, which has a radius of 1.5, a height of 15. Because remember, it's 10 plus 5 gives us that large cone, right? And now we just need to plug this information into there. Volume equals 1/3 pi times 1.5 squared, pi r squared times 15, the height. And that's going to get us 35.34291735. Now we're going to do the small cone at the bottom. Same formula. Different measurements. The radius of the small cone was 1. The height of that small cone is 10. We're going to plug it into the same formula, 1/3 pi 1 squared, radius squared, times height. And that's going to give us 10.471975551. And now if we subtract these two, we'll get the volume of the cup, what do they call it, a glass. The volume of the water glass. By subtracting these, we get 24.87094184. It said to round as the nearest tenth of a cubic inch, so that's going to be 24.9, and there you go. Okay?